So on to question number 2. They're saying that the common ratio of a geometric progression is r, and the first term of the progression is r squared minus 3r plus 2, and that the sum to infinity is s. So in the first part we are to show that s is equals to 2 minus r. So s is the sum of infinity, and we know that the sum of infinity has the formula a over 1 minus r, a being the first term and r being the common ratio. So we are told that the common ratio is r, so this will remain r, and for a we will substitute this first term. I mean sum to infinity is equals to r squared minus 3r plus 2 over 1 minus r. So in order to simplify this fraction, we will need to factorize the numerator of this fraction, and I'm pretty sure that one of the factors of this equation will be 1 minus r. So let's do it on the side over here. So r squared minus 3r plus 2. So we can write minus 3r as minus 2r minus r plus 2. Take r common, and this becomes r minus 2 and minus 1 over here. This becomes r minus 2 and r minus 1. So we can write r squared minus 3r plus 2 in this way. Now when we rewrite it, we get r minus 2 times r minus 1 over 1 minus r. Now we can see that we can only cancel out both these two factors if this becomes r minus 1. So the way we can do that is to multiply minus 1 with both the numerator and denominator. So this will become minus r minus 2 and r minus 1, while this will become r minus 1. So now we can cancel out these two factors, and in this way the sum to infinity or s will equals to minus, and when we multiply the minus sign in between the brackets we will get 2 minus r. This way we've proven that the sum to infinity is 2 minus r. So for part 2 they're asking us to find the set of possible values that s can take. So we know that for a sum to infinity to exist, the value of r must be greater than minus 1 and less than 1. This is because if the common ratio is r, then the geometric sequence will always have the same value again and again. For example, if the first value is 25, other value, the second and third and fourth, all will be 25. Same is the case with minus 1. So to find the set of possible values for s, we will now insert the values of 1 and minus 1 into this sum to infinity equation. And so if we apply minus 1, this will become 3, and if we apply 1, then the sum to infinity is 1. That means that since r cannot take any of these two values, that means that the sum to infinity or s must be greater than 1 but less than 3. We will not put equal to because it cannot have these two values.